Just by show of hands, just so we're situated, how many identify as like a developer or engineer in the audience? Cool.
Sweet.
Cool, right?
So with that, thank you so much for having me here, Nabil. This is super exciting. I love being in Vancouver. So, but kind of going back to Hackathon North, I'll try to keep this a bit entertaining too, and we'll make it less of an interview. But hackathons are not really that common, or rather, also they're not actually that old either. So 7 years ago, we as students would go to other events around mostly the US and a handful of places near Toronto and the Montreal region. And especially in the US, in the East Coast side, a lot of universities would do this thing where they had big enough of a school so that they can have their computer science students just kind of sit in a room or a lecture hall and sort of play around and just kind of make cool things. And that over time sort of expanded to, okay, we already have our CS class doing this. Let's kind of get nearby schools to show up too. And then it sort of became more of a production where, okay, we'll kind of figure out how to raise money for it. We'll arrange buses for it, and we'll just kind of go for people from even the next state. And we would kind of do these things ourselves. Because like it was just sort of like an interesting niche, and this is what everybody was into, especially if you were kind of programming and are you like doing that for fun. And it wasn't really common in Canada, and majority of us, it was like a big crew that would kind of go from Waterloo to all these other places and other universities. And most of it was just because that's the closest thing that was around. So we would be in a situation where we're in a bus for like 12 hours to go to Pennsylvania and stay there for like a 36-hour hackathon, and we'll spend like 12 hours coming back again, and we'd wonder why we're doing this again. But it just became sort of frustrating in a way that we just got lazy. Well, okay, why should we go there every time? Let's have them come here this time around. So that's primarily the motivation of it. In hindsight, it's a whole new set of milestones that it became. But the conversation basically went like this. Still no idea what hackathons is to the rest of the school. So we go to different faculties, and this is our meeting with the Dean of Engineering. And first of all, it took a long time to get that meeting in. And then the meeting was about, we want to have a hackathon in Waterloo, and we need your help to partner with us because we need a venue from the school. And the first answer was, what is a hackathon? And I was like, okay, we have to there's a lot more work to do now. So this is how the first meeting is going, the first 30 seconds of that conversation. And I go, oh, it's a place where just students come and just build whatever they want. And the follow-up question is, well, what are they building? And I say, whatever they want. And then they ask, well, okay, still I don't understand what this is. What do you need from us? And we go, we need the whole building for 3 days, and we can't have anything else going on in this building at all. And they said, that makes no sense at all.
On the weekend, and people
on the weekend,
sleep on the floor.
People are going to sleep on the floor. By the way, you may have liability issues with people who are not 18. And we'll take care of the rest. Don't worry about it. And then the next question is, well, where are these people going to come from? And we go, well, from everywhere, with no details at all to follow that statement. And they said, okay, well, how are you going to figure out how to make this work for 1,000 people? And we said, we got it. Don't worry about it. And this is sort of in hindsight the exact verbatim things that came out of my mouth that kind of did not work at that time, but essentially, we got to this place where we said, hey, we have a model where we can test essentially the interest from the students. Like Waterloo itself had a big CS and engineering sort of presence. So we got people to kind of do this thing. We had a core group of students that would go to these events. So we said, hey, look at all this interest. And we also just started to plan this thing and market it outside, and we could just gauge the interest. And sort of over the next few months, we got to this point where we were kind of able to convince them to just give it to us maybe just on the weekend, and we'll wait until classes end on a Friday and just kind of take over that building. And that's sort of essentially the leap of faith that the Dean of Engineering took on us to realize, hey, students want to do this thing. And essentially the pitch back then was, everybody knows that Waterloo is known for its co-op program. And a lot of those benefits come into play when you are going into sort of a full-time job, because you've had enough internships in real companies and you've built things, and so you kind of know what that looks like from what it means to ship. And it's not just a scenario where you did something in theory in classroom and suddenly have to go to the workplace and then figure out how that actually works when you're coding something up. And our pitch was that this actually becomes a playground for them to actually test this out and just have fun. And actually, this is how you offset theory with applications and just make it fun, especially for first and second year students. And that kind of just clicked. And it sort of became that event where people actually do this to try out what they can and cannot do with what they want to do for the rest of their lives.
Yeah, and what I found remarkable, because like 2 weeks ago we were in Waterloo at the 6th iteration of Hack the North with the dean, and she got up to give her speech. She was very emotional and she started crying, and she said, when you guys came to speak to her, you're a bunch of young cookies, her words, right? And she said, you're in physics? Like, why am I even talking to you, right? And then she referred to Liam and said, well, computer science. Well, and then ultimately the saving grace, she said, was Kevin, who was actually in engineering, right? And so, but really what happened was something special, because you were way oversubscribed on applications. You only wanted to select 1,000 hackers, right? And each successive year you've gotten way more applicants. So now it's like, it's an 8-to-1 ratio in terms of what you accept. And it's kind of like a military operation where everything has to come together all at once within a certain time frame. And as I walked around campus this year, like seeing those air mattresses pre-blown up and all the infrastructure, all the tools and the hardware and the software that you bring together to literally create the largest collegiate hackathon in the world was pretty substantial. But I want to move past that for a second, and I want to talk about how you've taken the hackathon playbook, kind of effectively open sourced it, and you've kind of applied that down the line 5 years later to the Ethereum community in the form of what was ETH Waterloo, which quickly turned into a giant global roadshow of ETHGlobal, which you co-founded with similar people. And so can you talk to me a little bit about that, and working with the founder, inventor, and creator of Ethereum, Vitalik Buterin, and how you've again taken a model that works really, really well and basically applied it in such a way where this year alone you're probably going to be on all 5 continents in the world.
Absolutely. So the thing that made hackathons, or actually Hackathon specifically, interesting was it was always marketed as sort of a risk-free option to try something out. And what that was essentially a sandbox to just play with things with no sort of expectations or constraints on what you can and cannot do. The only limitation was that you have to do something within the 36-hour window from like Friday night to Sunday morning. And we saw this with students where they would come in and obviously, like a lot of them would prep for this ahead of time. It's like, okay, I want to build this thing for this weekend. This is already my team, and I'm gonna like spend 5 hours doing this, and then they'll spend 10 hours doing this thing. I'm gonna sleep when they're doing that, and all this like intricate sort of plan around what they can accomplish in that 1 day and a half window. But what it actually turned out to be was, not only was it a place where people who were studying CS or engineering were sort of coming in saying, let me just do this thing for fun, because anywhere from I need to have something on my resume to maybe this will help me understand how to use the technology that I have to use at my internship next semester, or I'm graduating, I need to kind of use that as a way to talk to other companies and get a full-time offer. This became a way for people who were not in that position to actually try out and see what could be possible. And we didn't actually even think about that when we were doing it for the first year. And essentially, it was the moment where, after the first couple of events, we got all these emails saying, hey, like I'm not even an engineer. I didn't realize I would be able to do something like this thing, or I kind of knew about programming, or I knew HTML, but I came here for 2 days and I was like, oh, I'll just give something a shot. I met these other people from these other countries, and we just did this fun thing, and we also won a small prize. And now I'm actually considering switching to CS, or I'm actually considering switching universities to move here, or like change my program. And like we never thought this would be the case, but that started becoming a lot more common over time. And this was sort of the magic moment that we saw that, hey, you can actually give people this sort of demo world and then have them sort of be interested this way, instead of learning about, hey, like a software engineer should be an engineer because it pays high salaries, or it's fun, or because everybody else is doing it. And nobody else had that alternative back then. And kind of the same moment applied to us when we were looking at ETHGlobal. And essentially, the moment that was sort of figured out was, we wanted it to be a place where Hack the North had a student focus, so we wanted it to be very much about students figuring out what they want to do. Here, we were kind of skeptical of seeing, let me back up a second. For Hack the North, you're not told to solve something specific. you can do whatever you'd like, and we want to just have enough resources there, anywhere from mentors to technologies to kind of even companies who are building these technologies, be there to help you if you get stuck. We wanted to see if we can actually make this possible for something that is specific and not fully open-ended. So which is, let's just focus on one piece of technology, which is Ethereum. It is a platform to build a bunch of other things that can still work in an open-ended fashion. You can do anything from healthcare to finance to games. All this is possible, but can this actually work for something that is figuring out what it could be? And can we actually make that a bit of a faster curve on adoption for what this could look like? So we said, hey, like, I think we can possibly make this work. We demoed this thing by doing this first event called Waterloo, which was 2 years ago. And a lot of interesting things came out of that. So the most obvious one that most of you may know of now is CryptoKitties. That was a project that came out of the hackathon 2 years ago and evolved to be sort of this massive thing that everybody now knows, as well as his company. But the goal was to see, can these moments, which happens to be in Vancouver, Axiom Zen. And we never thought these moments would come, and we're trying to see like how we actually can make that work in other parts of the world, because as kind of Nabil mentioned before, like the thing that actually makes possible, well, the technology makes possible now is you can actually reduce the access to different things a lot more abstractly. And if the engineers are in different parts of the world and they're only constrained by finding either capital or other people, that gets harder to kind of compartmentalize. But if this is purely about everything lives on a computer that is accessible by everywhere and everybody, then what if we just bring the show to them and see what they can do, and if there's actually a difference that we all kind of project, but we never get to see. So ETHGlobal was a way to test that out. We've done 14 events so far around the world, and these are all different cities and countries that have significant tech presence. And every time you go there, you realize that they're no different than Vancouver or Toronto or the Bay Area, because there's still concentration of really talented developers there. What just kind of sucks is that some of them don't have access to the same set of people to actually enable them to get to where they want to be. And we're trying to see how do we actually make that go down in terms of the margins of like how do we actually make that more possible.
And part of what like made it world class is not just the resources for the students and whatnot, but the opening ceremonies, the speakers selected. It was first year Chamath Palihapitiya, and then you had Vinod Khosla from Khosla Ventures, and Sam Altman, first time ever he's visited Waterloo after making 24 investments, right? So on the speaker side, on the opening ceremonies, but then on the judges side, in terms of like the mentors who and the people who are judging the hacks, was truly world class. And then first time ever Apple has sponsored anything in the history of Waterloo region kind of thing. But also you have like Google and Microsoft and others sponsoring alongside. So that's what allowed you to fly people from as far as China, Russia, you name it, you name the country. Hack the North was bringing them in that respect, right? So there was that, and then you got the interest of even the Canadian Special Operations Forces Command, as well as like the communication security establishment in terms of the Canadian intelligence community, and all these people who wanted to sponsor this thing because they wanted access to extremely passionate young people who want to solve really tough problems kind of thing, right? Or create. And so I think that was particularly special, and that's partly what made ETHGlobal so successful, is it had this unfair advantage of knowing with the same founders effectively how to execute a large-scale hackathon and bring the right ingredients to make it epic, basically, right?
Absolutely. I think Nabil's already better at answering my questions than I am. But I think a lot of this is that in hindsight, when we talk to either other events or a lot of time I get emails from other university students organizing events in their school, they talk about, hey, how do we replicate the whole thing? And to be honest, it's none of that was the plan. We just wanted to do this one event, and we're like, hey, we did all these things. We reversed how we should get to that result from the day one, and we said, okay, if we have to do this as the outcome, let's see what else we need to do to get there. And that sort of became set up in a way that we had to formalize so many of this. And the interesting thing is like, slightly, I think maybe I would put more weight on is when others kind of think about that, or at least in our conversations with other schools or other students, they would never think of it from the context of you essentially, the problem with like most student run things is that there is a lifetime of like when things kind of just die, which is when either a student gets busy with like their second last or last year of university, or when they graduate, and then the whole context is lost. And nobody kind of does the planning for what happens after you're gone. And we kind of designed it so that like even if we disappear, can you follow this exact instruction to replicate the exact same thing? And the benefit was, even if somebody reads that verbatim and with a typo does the exact same thing that's wrong, at least it'll be consistent to how it was done the year before. So your absolute worst case is the floor for like how the last year event was, and you just have to find people who can take over and actually make it better for the next time. And we kind of designed it from that perspective, and we realized that nobody was doing it from that side. So a lot of this was like, in hindsight, this made sense, like, oh, this is a smart thing to do. But we never thought of it that way, and we just kind of get the credit for making that work. And when we're thinking about doing ETHGlobal, it's just that, okay, well, you have all these things that you know about what to do and to make it experience consistent. The question is, what do you lose when you go into a different country where you have no advantage or a presence? And like, how do you think about making that now the same event experience somewhere else? And this is a whole set of interesting problems, because like, one, that's fun that we want to solve now. And we think of it as like, what if you have now a box that always has the same thing in it wherever you open, but you have to kind of figure out how to get the box to this new place. And
work with the right partners as well.
Working with the right partners, like, I mean, I know way too much about how to avoid basically duty charges for getting stuff shipped from different countries to different countries that I never thought I would have a handbook on, or things like, if you ever stuck with some scenario where you need to feed 300 people in a 1 hour notice, what can you do about it? The answer is you open Uber Eats and get 40 pizzas from Domino's. Then they get later stolen by your Uber Eats driver. And they have to figure out how to get 40 more pizzas in the same 30-minute window.
Just for like context, like ETHGlobal went from Waterloo to Denver to Buenos Aires, Argentina to Bangalore, India.
We did Cape Town in South Africa. We did San Francisco, Berlin, and Paris. So it's like
Singapore.
Singapore is another one. Yeah, Nabil's wait. I think Nabil should just answer my questions.
I did a lot of prep. I did a lot of prep for this.
But the question is like, if you can just make the event experience consistent, will we get the same results? And the thing is, we're realizing over time is that actually is true. And this is sort of a new insight into that it really is about the opportunity, because talent is actually everywhere. And how do we actually bridge that gap in terms of making that shine a lot more?
Yeah, and you know, that's actually one of our central theses, is the talent being universally distributed while opportunity is not. And so how do we, you know, level the playing field? How do we build those bridges? You know, and that's what we're doing here at Terminal. So maybe we can use this a bit of a segue to talk a little bit more about the second kind of key topic area of like engineering, and if you can, you know, maybe give us some insight into some of the engineering leaders that you might have come across or worked with, and also maybe also pay a little bit of attention to specifically decentralized teams, because even I believe the first 20 people that organized Hack the North never met each other before. They were part of a decentralized team. So can you talk to us a little bit about how you think about that, and then we can maybe after that we can talk a little bit about the Valley and the Valley culture and what makes that special, and how do we, you know, take some lessons from that.
Yeah, absolutely. So one of the interesting things about doing this as Waterloo students was that Waterloo has this co-op program, and they have different streams. So like, you could be in a different stream and you'd be offset by another student. So somebody could be in a study term and somebody would be in a work term, and you could be off by one. So every time you're in a study term, somebody could be in a work term, and you can, depending on where you get your job, you may not ever be in the same place. So we had about 20 people in the first year of organizing the event, and and this is sort of 3 semesters worth, every semester being 4 months. And the interesting thing was, we actually didn't even realize until like a year or two later that almost everything we did happened online. And about half of us had never met each other in person until like the day of the event on a Friday, because we were always on a different schedule. So like, none of us were in the same country or in the same city or even in school. And this made it super interesting, because you had to, one, kind of work with people who are obviously in different geography than you, but also make sure that there's a whole process around how do you make the experience consistent, how do you follow up, how do you think about relying on somebody, and also like, how do you actually work together when you have this large of a group, and sort of like the connections between each party knowing everybody else is just way too high. and we had all these sort of processes in place where the biggest thing was like everything must happen on Slack, and you could not have a side conversation anywhere else, and we'd be like kind of penalize people for doing that. The second one was like, anytime a meeting happens, you have to have like notes about it so others can catch up. As being engineers, all of our stuff was on GitHub, so people were just literally reading like differences of like the commit logs of what happened in a meeting or an outcome, which was like a crazy thing to do. I would not recommend that anymore. Use Notion. What we actually ended up being in a position for was that we actually managed to figure out how we actually work with each other and sort of like naturally understand who should be responsible for what, and also figure out, depending on our availability, where it makes sense for somebody to take the lead automatically, right. And then have like cover for somebody else. And there was this point in time, like the week before the event, I remember sending an app message channel or ad channel message on Slack. And this is about 22 people in the Slack group. And if you remember, Slack kind of reminds you that if you're sending an ad channel, that there's like different time zones or people might be sleeping. And I see the message saying, you're about to send a message to 22 people in 12 different time zones. Are you sure you want to do that? And that was like a moment where like that never was planned, but somehow we never thought about that because that was our default. And we managed to learn about how to actually communicate with each other and actually have a process around you only have one place for talking and then one place for decisions, and that's the only thing that worked for us.
Is this the time when you wrote an API for the university? No, can you talk a little bit about that and shorten that answer if possible?
Yeah. So this is before. This is a couple years before where that started. So when I was a student, I spent a decent amount of my time working on campus, writing a university API, and essentially this started as a. I never talk about this story because it sounds really stupid, and this is sort of the length I've gone to make this work. A cafeteria on campus had really good waffles, and but it would be really inconsistent on when they would serve it. But they had a menu online that you have to like refresh every morning to see if they're serving those meals. So I wrote a scraper to notify me if that meal is being served. And in process of doing that, I was like, oh, I can write a scraper for the food. Let me do that for the schedule. I'll do that for the exams. I'll do that for like the book line. And I'll do that for basically 20 other things. And like 3 months later, I had all these things pieced together. And I just announced it to like a bunch of mailing lists on campus for like the CS Club, and there was an open data initiative. And turns out that like people are like, oh, this is kind of neat. And I get an email from the university IT department saying, we'd like to talk to you with no other details, which usually means that you're in trouble. So I was like, what did I do this time? Let's just kind of figure out what's going to happen. This is like first year of university. I have no idea what's going on. And they said, hey, this is actually really interesting. We've seen that even our internal staff is using this for a bunch of other things. Would you like to just give this to us and make this official university API? We'll just actually integrate with the data sources, and you can manage all these things directly. So it was like a whole new turn of events where like I didn't realize this was even a thing. I was definitely not confident on that code base integrity, but it ended up becoming the official API for university and sort of powered everything from like how the different faculties kind of work with each other to the exam schedules to the scheduling API in general. A lot of the students kind of use that as a way to learn programming. It actually became part of the CS curriculum over time for the first year students, like how do you actually make this work on, we're going to do some real world applications. And that sort of turned into being a thing where like I never thought this would be the outcome, but it just kind of goes to show that like things people are doing for fun can eventually turn into something bigger than that.
So sticking with that, like that engineering side and specifically open source. So on your GitHub repo, you have a number of projects that you've written. Could you talk about some of the more popular ones that have been widely used or downloaded? Maybe some of the ones that come to mind are even the personal time management or some of those other tools that you've built.
Yeah, sure.
Or just pick your favorites, basically.
I'll just talk about one bigger open source one, and a lot of these are like hackathon ones. I've ever since sort of focusing on the investing side, I don't get to code as much, and I miss that, so I just kind of do like fun things to like automate a bunch of stuff that I do on a personal basis or like work related things. So those are like the random snippets that you find. But one of the biggest projects that got sort of famous in hindsight was this library called gmail.js. And this is about 2013, so quite a while ago. And the whole premise of this was I was at a hackathon. I don't remember which one anymore. And we wanted to just do this fun thing and like add a to-do list to Gmail back then. And we said, okay, we'll figure out how to do that. We'll make a Chrome extension so people can have to-do list items. And the problem was this was the time where Chrome was getting popularity as a browser, and we kind of saw the potential of Chrome extensions, so everybody was kind of going after, let's just make all these extensions work. And Gmail was the biggest tool everybody used, and they had like 500 plus million users, and everybody was switching to Chrome, and people said, okay, I can do all these things. You have the CRMs coming in, you have the pixel blocking or pixel tracking stuff, you had all the CRM enterprise companies making it work with Gmail. And the problem with all of this was Gmail has a very intricate code base, and if any of your developers just inspect element on gmail.com and you realize what I'm talking about. Making that work is not easy for anybody, and everybody was doing their own sort of solutions for this thing. So we were doing this hackathon, we went just literally at a to-do list on a Gmail email inbox page, and it turned into sort of a way where like, after looking at the code and staring at like what Gmail was doing and seeing what everybody else was doing in terms of like repetitive efforts, I just decided to sit down and said, let me just like make all these functions as helper functions. So I'll be like, oh, if you want to add something to the sidebar, you just kind of call this and like paste in this HTML, and we'll just inject it and we'll figure out what's going on the page. Or like I spend time reverse engineering the network API so you can understand like how do I hijack like a call to if somebody's sending me an email, I can pause that so you can have a pause button on your inbox. Or if I send an email, I want to know like the email has been sent so I can do something else. All these sort of like small things people wanted to do that we're doing custom, that nobody actually spent time kind of consistently like actually abstracting away. And I just had a list of these like 100 functions that I wanted to do, and I just put them in a library and just put that up. And I just kind of put that on Hacker News saying, hey, like I just made this fun to-do list thing, check it out. And people were like, oh, I don't really care about that part. How are you doing the Gmail thing? And could you open source that? And that turned into a massive thing where over after 2013, when it came out to the last like sort of 4 years, I've got emails from every single enterprise company that's making a Chrome extension. Like LinkedIn used to use it for a while for all of their LinkedIn APIs or their LinkedIn Chrome extensions. And it got to this point where this single library was powering a few 100,000 users on Chrome. And one, I had no idea that was happening because I was like, oh, this is fun. We'll just do this thing. And every now and then I would get a bug report saying, can you fix this? I'm like, yeah, sure, I'll do this thing and like not think about that. But that became sort of super powerful, and sort of that spawned a whole era of like where people wanted to actually bring that down and actually manage that themselves. So that's just one. And the rest of it is like, I have a handful of scripts that I either tweet about or put on my GitHub, which just make it easy for me to do my daily work. So anywhere from like scheduling or managing time zones or like automating a bunch of workflows that I have, that I also have stuff online that now I spend time on when I don't get to code for fun.
Fair enough. And if you care to follow Kartik, it's at @TheRealKartik on Twitter. But you know, in 2014, you got a job as a co-op term as an insight engineer at SV Angel, right? And so I want to start to move into like the investing side of this conversation, and then we'll open it up to the floor for questions if you guys have any questions you want to bring in. So, and that's where you really got access to this really interesting data set, right? I mean, when we talked about the description of this event, we talked about the Ronco Principle, which is an essay that Paul Graham wrote about, Ron Conway, who's widely regarded as, one of the, if not the, greatest angel investor. So you worked with, SV Angel, and you had this unique data set. I think it's 500 companies, 1,000 companies? Or?
No, so SV Angel would see on average about 10 companies a day. 10
companies a day. Yeah, and in fact, one of the VCs in this room was asking me about that because they were talking about their portfolio and they might have some questions about that. But so, and then you basically built this custom CRM to figure out, all the relationship management, I guess pro rata, some of the, the things that you need to really keep track of when you have such a massive portfolio. And of course, some of these investments were, the big tech brands that we hear about today, Google and Instagram and these sorts of companies, right? And so after you graduated, because you did see it through, you did join SV Angel as a partner, and today you serve as an advisor. But Can you talk to me a little bit about your transition from an engineer to an investor and what that was like?
I never thought I would want to be an investor, nor was that the plan. I just liked solving interesting problems, and that just turned into this thing where that just got to where I am now. So back when I was interning at SV Angel, and I joined the investment team after, but also as an engineer first, was essentially SV Angel is a seed investment fund. So when we're talking to a company, it's almost the first conversation the founders is having with an investor. So like the common scenario for what an email that would come to us would look like is, hey, we're two founders. We've worked with each other in this. We were here before. This is what we're working on. Maybe here's a deck, and this is what the company is called. So there's no website. There's nothing you can look at. 3 months later, they might not even be the same pitch. And this is the stage you're talking to a company, and this is the stage you're deciding on backing somebody. And doing that for over a decade, essentially when you have about 10 new companies coming in a day, that compounds really fast, and you have like 50 to 100,000 companies that you have in basically just you've talked to since the existence of the fund. And the problem is, from a technical standpoint, that obviously there's new people moving into the Bay Area or in the world just starting companies, and they want to talk to you and they raise money. But a lot of these times, like, it's the same founder, so some companies work and don't work, and they kind of move on and try something else. So now it's a different name, but the same people, or the idea was something back then, and now it's pivoted to this new idea, or the company used to be called something, and now it's something else. And losing track of that information is super easy because nothing exists online. Like, I can't even Google half the things that I look at because nothing exists. And the goal was for us to actually figure out if we can actually gain any insight from that information, and also just actually map that out better. And the position you get into from there is, not only do you get to understand like the timeline of like how things begin, you can maybe draw trends from it, which is anywhere from like predicting, hey, this person has been in this position for, not a founder, but like this person who joined as a VP of sales or something, or head of engineering for this company is about 3 years ago, and we noticed that like right about this time, people start considering other opportunities, who could be in a position to like move to a different place, or because of like the founder's background in this, they're working in this now. So if I want to talk to somebody who really understands this particular topic, how do I go to them? Or something, even things like, if you track all your email data and you kind of index like the times, you can have a map of, if I email this person, I can get a response within this time window. So if I really want to get to somebody, who is the best person to email at this company or at this domain name to get the fastest response? Like all these like weird things that kind of matter or also not matter, just for fun too. You kind of got to do that. And the biggest part of it was like, with this information, could we have done better at our jobs? Because SV Angel team, when I joined, was like 6 people on the entire investment team, and these 6 people are managing the entire pipeline of talking to the first interaction to making that decision. And when you have like 5,000 companies to look at every year, like knowing what's kind of happened in that space or that industry, or even the life cycle of a company, is super important, because that is the advantage you have. And you don't want this to be in your head, or you also don't want to forget this thing. So like that was the goal. And in that process, on top of just kind of learning more about that, it became sort of common for me to be in a lot of these meetings, and my interest being very technical projects, and with like a focus on open source or networking and crypto. Like I just kind of became more and more in those conversations, and sort of kind of starting off as like just kind of being the person to ask the right technical questions, that evolved into a place where like I just got to this sort of place where they were like, hey, are you still enjoying this thing, even though you're not, like, even though your primary role was like trying to be an engineer, and do you still want to do this thing, and also can you just do this thing yourself? Like you can just take over that meeting. You don't need us to kind of manage that. So that evolved into this thing which I never thought I wanted to do, and I realized this is kind of fun because I get to learn about all these things. It's kind of unique to be in that position. These things don't come. You can't apply for something like this, and on top of that, like I have way too many interests and a very short attention span. Right. So it's like, oh, I'll jump into networking, I'll jump into something social, then I'll go back to D2C or something and go back to crypto, and you just get to be informed about everything else that's going on.
What's it like working with Beth Turner?
It's great. The best thing about the SV Angel team is that I I don't even think this was designed that way, but all of us have very complementary skill sets in terms of like what we cover or what we're really good at assessing. So anything from consumer to enterprise crypto to biotech, it just kind of came to be in a way that like we still work together and like kind of being in a position where you're in a unique situation where 6 people know enough about everything that's going on in terms of every sector they can cover. I just thought that was like unreal. And I never thought this would be like a common thing anywhere else. And like when you come out of that bubble and just talk to anybody else, you're like, oh, like we don't touch this sector because we have no idea how to evaluate this thing. And that's just like a really fun thing that I never thought I would be in.
Right, right. And so just on moving along then, now you're a general partner at A Capital, right? And so that's also a really small and
yeah, so A Capital is 3 people on the investment team, right. And we do the same thing.
Yeah. And so can you talk a little bit about the formation of A Capital and some of the deals, multiple, if you can?
Absolutely. So A Capital is cleverly called A Capital because they focus on Series A investments. And the history of the fund is, it was started by Ron Conway, who was the first hire, or the first person to start Google Ventures, and then sort of he was the first person on the Andreessen Horowitz team when they were starting in 2019. And Ronnie kind of took over the early stage investment in Andreessen, and he was sort of responsible for investments like Instagram and Pinterest and Twitter back then through Andreessen. And he kind of was with the fund until 2013, and this is sort of the era where
2009 to 2013.
2009 to 2013, correct. And this was the era where we started seeing these mega funds sort of come up, and these are like the funds with like $1 billion investment thesis, or rather AUM, and they're trying to invest in sort of companies in this space, and especially with the early liquidities that kind of from the companies that went public in that era, it was kind of becoming a scenario where companies would raise a seed round. They have the same window that every other seed company has, so like 12 to 18 months to kind of raise the next round, while still figuring out what the product looks like and kind of the thing they have to focus on and get the product market fit or just even get users. And then because the abundance of capital, they would immediately go from like a $2 to $4 million seed round to like a $20 million next round, which like it's kind of offset a bunch of incentives. Like you kind of were in a way forced to sort of pick a path and just like stick with it, even though you don't know if what you initially wanted to do has worked or not. And that sort of became an issue where we thought there was a new way to kind of take advantage of that middle part, where going from a seed to not a mega fund, but what if you can redefine what a Series A could look like? And that's sort of the rationale behind starting in capital, and sort of the value prop was that we want to work with founders and we want to work like seed investors and early investors, but we operate in a way where we're flexible enough to figure out what it actually means to kind of get you to that new mark of being still more hands-on, still making concentrated investments, and then also not compromising on a handful of other things that, because of the nature of other funds out there, they have to. So anywhere from we need absolutely 20 or 25% ownership, and we need to take a board seat, and like if we make and if you don't agree with that, then goodbye, and we can't budge on all these things. So we actually want to be flexible enough to actually work with the founder, help them figure out how to get to the next phase of getting the product market fit, and then sort of stick to the bigger funds to go with your growth round. When you figure out things are working, then you figure out how to scale that up. And that's kind of the thesis around how A Capital was formed. We have 3 partners, and all of us have our focus. So I focus on crypto, Ronnie focuses on consumer, and Ramu, the third partner, focuses on all of enterprise. So it was still a multi sort of sector-based focus on how we look at everything.
And both of them are your age as well?
No, they're almost all a lot older than me, which is always interesting because seeing.
But you don't
Sorry to throw you.
No, it's all.
Yeah, no, like because we got a little personal over lunch today, and we were talking about a bunch of things, and one of the things I was just curious about personally was like this whole notion and of like imposter syndrome in tech and this sort of thing, where you want to get a job that you're not qualified for because you want to be constantly stretching yourself, you want to be going. And so can you talk a little bit about like some of those moments that are like,
oh yeah, that's
and
every day.
And I say that fully in awe of you, like personally, but like but honestly, like can you talk a little bit about some of those moments where you're put into meetings and you're asked to do things where you're like, whoa.
So the interesting thing is that it's an advantage and also a disadvantage, which is you don't really know if you're a good investor or not, because that's like a 5 to 10 year cycle to see the outcome of a decision you've made. So the question is, how do you get better in this scenario, and how do you actually figure out or either converge on a specific path to see if you can test this out? I am just starting to hit that point right now to where like some of the early investments from like 4 or 5 years ago are starting to get some initial traction and or like at least becoming much more known products. And that still doesn't mean that they're like the winning anywhere from company to the market category in whatever sector they're in. And that's kind of what's interesting, because everybody else on the team is has seen enough of those sort of cycles, kind of being early from like the whole dot-com bubble to like seeing it from kind of being part of Andreessen, or the companies they invested in the seed stages like 10 years ago are now kind of anywhere from IPO to later stages, and they get to see what does and doesn't work, and you can go back.
Like part of like your bench strength too in assessing crypto investments is your ability to go well past like a PowerPoint deck on any ICO and whatnot, and literally look at the code, or like what is the tech here, right? Because that's a big problem in the crypto space.
And this is exactly, so it's like it's hard for me to say like this is what makes a really good consumer company or this is what makes a really good marketplace, because you don't know that just yet. You can hypothesize, but you can't confirm that. You need to figure out how to balance that or counterbalance that. I found an easy way around it, which is I'm going to focus on things that I understand and not try to pretend to make a judgment call on things I don't. And to me, that was math and code, and that's what's interesting about crypto. I just had an interest in this space for long enough that it was like, this is obvious to me from what the thing is to what's going on in the space.
So let me ask you this question. If we play this thought experiment where 5 years out, crypto has failed by a wide margin to deliver the promise that, is all, the rage today, right? What went wrong, or what are some of the things that, would limit its ability to reach its full potential? And then I have a follow-up question after that.
Cool. So the hardest thing about investing is being able to actually make a better answer for like, is this the right time to do something? Like the standard why now question is actually the only thing you're actually evaluating when you look at some company. And that's hard because you can't predict the future, nor can you predict like how timelines would kind of converge on certain outcomes. What kind of gives me slight comfort, at least specific to crypto, is that there are certain types of companies that have to bet on people caring about them, and then they can figure out how to make it efficient. And there's nothing wrong with that approach. A lot of them work this way. A lot of the common things we use are in that manner. So anywhere from a social network that just has to get people to use it, they can make it faster. They can figure out how to handle scale as they grow. But crypto specifically is in this unique position where if it doesn't work in theory, it likely will never work in practice either, because you're fundamentally you're making these things based off of mathematical decisions for like what it means to anywhere from gamble on the economics of a network to like the assumptions you're making about something from a pure technical standpoint for like, can I confirm this transactions, or can this be gamed around something? All these things have to be proven true in theory first. And if it doesn't work then you almost always know that's not going to work out in practice. That kind of makes things slightly easier, because then you're not betting on the technology itself working. You still have to be in a position to say, will this tech be used anywhere? And that's kind of the phase we're in.
Which is what gives maybe Ethereum a bit of an advantage with ETHGlobal and the prototyping of all kinds of ideas with thousands and thousands of developers, right?
9 out of 10 companies fail already, independent of them being crypto or any other sector. And the hardest part about kind of getting something to work, especially as investment, is that changing human behavior is not easy, and people don't really kind of like their routines being modified. So what does it take for somebody to actually make that work? And like the traditional answer you get is like, it has to be 10 times better than whatever's happening now. So like if you think about the taxi case, like, do I call and wait for somebody to show up and maybe I'll get a call back saying they're here, or do I just press a button and I can track it and I can pay for it directly and I don't have to worry about anything?
I think I've lost track of time, and I want to make sure that the folks in the audience have a chance to ask their questions. So if we could just pause you there.
Wrap this up in like 30 seconds.
Cool.
And essentially crypto right now is in a place where it's a technology looking for a problem. So you have a solution, but you don't know what the problem is you're solving, because so much of it is possible. And and essentially the question is, are we in a place where either we just stick to something that we already know, we understand that works really well, and we just say, okay, let's just use anywhere from a blockchain to this specific new math to make an existing workflow work, or do we think about what else is possible now that we never thought was either possible, we didn't imagine those scenarios? And that's the battle that I see that's happening in this space. And the answer I have to that is essentially you can offset that by more experimentation. And I think it's more about the reason kind of ETHGlobal exists and we kind of do this more actively is if you can increase sort of the kinetic energy of what's going on in terms of experiments, you can have more outcomes that people can choose to converge on. But you can't wait for somebody to say, hey, we solved this thing and this is the best case scenario for like what we think we can use crypto or blockchain for, and then we hope that others also agree with us. It's like, let's try 500 things in parallel and maybe 3 of them will work, and then let's see how big any of those 3 things are. And that's kind of the approach that I think we're taking, and this is the biggest kind of hurdle that this whole space has to figure out in the next few years to determine if it's going to be it's going to take off or not.
All right, well, with that, I want to turn it over to anybody in the audience. If I could just ask you to project your voice when asking the question, if we have any questions in the audience.
So the question is, can I give an example of like what the assessment looks like for, this is crypto specific, I guess, or just on the investing side? Got it. So any investment that like kind of we look at it from a technical standpoint and see what that converges to. And kind of interesting one is, so there's this company called Near Protocol that we invested in, and sort of the value prop is NEAR, Near Protocol. It is a blockchain platform that is making it easy for you to deploy more decentralized apps and is solving specifically the intricacies of the kind of the problems you have on the consensus layer for Ethereum, which is right now everything behaves like a single pipeline where if the system can handle 10 transactions per second, adding more of these chains doesn't actually parallelize it. You have to figure out a better model to actually bifurcate the data from the messages, and that's called sharding in terms of the database terms. So how do we actually have efficient shardings and still maintain those trade-offs? So when sort of a company like that comes in to pitch you, you're understanding sort of what their approach is to sharding, and this is also kind of overlaps with a handful of experience I have in the database sector itself in scaling database data centers at companies like Salesforce, where I used to work before this, where you get to understand like how do these trade-offs work in practice and sort of what the latency considerations are for the data itself to be like either the retention from the first shard to the second shard in terms of syncing, as well as how do we actually enable anywhere from like these are the problems we have with, let's say, the EVM, which is the platform you deploy the Ethereum smart contracts on, to make it a different runtime. Like, how do we actually balance all these things out? And all that sort of experience comes from anywhere from playing with these technologies myself before, or understanding like, hey, this is what works in the, let's say, the node ecosystem, and we can convert all this to EWASM, and then from EWASM, like, I think we can make it work on this chain, and we can have like an execution environment that gives all these consistent guarantees, and you kind of get to piece together all these missing things that we know that are open problems, and being able to just kind of assess that anywhere from like on the research paper that they present you to how their sharding works or the consensus layer works, to seeing the code base on GitHub and just saying, let me just try this out and see if the Hello World application actually runs as expected. All these sort of things are like sort of unique that most other VC funds sort of are not in a position to do, and that kind of also makes it fun for me because I get to code this way as well.
So what can you tell us about centralized finance in the realm of Ethereum, and do you think it has a lot of promise?
Decentralized finance, DeFi, has been growing as a pretty big narrative in the Ethereum ecosystem right now. And sort of the thing that kind of clicks with a lot of people is if you think about programmable money, you can actually consider that as a building block. Which is composable, so I can like piece together a bunch of things and anywhere from like have a chain of steps that happen to just kind of make that a bigger set and then just do one specific thing. And that's kind of like the fundamental backing behind decentralized finance. So you have something like I can deposit some money as a collateral, and I can take something against it, anywhere from a different token to a stable coin that has like a same value, and then I can use that for other applications like lending or investing in something in somewhere else, or like leverage-based scenarios. And you have all these sort of different blocks. So like I can have an index fund, I can have a margin trading protocol, I can have an options and derivatives. And we're trying to see what these combinations are that can work in an existing sort of realm of how we think about things. What's interesting about this is that all these things are like not new. Like we understand how ETFs work, we understand how derivatives and options work. There's certain nuances for like how do you replicate like an ETF or a derivative in like a decentralized world where you can have certain guarantees but you can do certain things. But what DeFi brings to this ecosystem is a lot more transparency around managing what's going on in terms of the risk profile. And anywhere from going back to like the 2008 crisis, like a lot of this failed because we had no visibility into like how things were designed. Fundamentally, the way Ethereum is set up, you can inspect and actually understand how the dependencies are structured with each other. And this makes it a lot easier to at least predict what's going on. It doesn't mean that it's a great alternative just yet. I think we're seeing the applications come up. I am particularly super interested in sort of seeing what we can do that actually finally makes it to the everyday consumer. The thing about like all these financial instruments is that like I don't really do derivatives on a daily basis, neither does anybody else on this room, unless you are a trader or this is your profession, you don't really think about that. But we haven't really spent the time as finance industry or even as tech industry bringing those instruments to like kind of just everyday use cases or even the everyday audience. Whether that means like making it easy for them to access this with something like Robinhood or just even simplifying the experience so they don't even know what's happening under the hood, but you get the same exposure or the outcomes of like any of these instruments. And I think DeFi makes it a lot more possible because like you essentially are making this setup where a single piece of smart contract can be full-on bank account that needs absolutely no infrastructure to run, anywhere from a branch to like people. And you can have everything from a checkings account to a saving account to an ETF to a bunch of other things that every traditional bank offers, but now represented entirely as code. And I see there's a lot of potential in that.
So like two-part question then in terms of decentralized people, right? And so obviously you're an investor, we've talked about the Valley a bit, but the reality is like if you talk to most big funds, any of their investments past an A round have another office outside of the Bay Area or whatever the case may be. So this kind of trend on decentralization. Can you talk a little bit on the crypto side? You mentioned a lot of your investments are not in San Francisco and that sort of thing. So can you talk a little bit about what you think about decentralized teams and sort of like how you think about where to find your next investments when it comes to crypto and what are the ones out in the wild right now that you actually have made?
Yeah, absolutely. So the super interesting thing about crypto is that I think it actually leveled the playing field for a lot of people because now they had access to not only funds, but the capital cost of getting started was almost reduced to zero. And what I mean by that is if you were a company, you would have to, and you were making any app, you would have to buy a server and you have to deploy your code there and essentially maintain that. And as you grow, you have to make sure that you have enough money to offset the cost. And the way consumer applications are designed right now is that things are subsidized because usually you want to keep it free. What actually became sort of interesting for the world in crypto was that for things like smart contracts, the cost of deployment is actually just fixed and one time. I write this like 10,000 lines of code, for example, and I say, okay, I want to like now make that go live. And I say, okay, this code is going to cost me like $20 to deploy on Ethereum, and I press the deploy button, and as of that moment, it is live and available for everybody. And it kind of took off that whole notion of like I need to have a server now to maintain the logic of my application, which is like a really new perspective that we just didn't thought would be possible. So like the costs have just kind of gone down to zero, and that actually has enabled a lot more people to just try things or actually just work on things without even being physically in a certain geography or having the upfront capital to do it. So you get to like reduce the barrier to entry for trying anything out, and then once it scales, you then spend the time to make it more efficient. And this is why like a lot of the stuff we're seeing in crypto has been basically all over the world. You kind of like finally realize that there's so much talent from great engineers to great researchers or great mathematicians and cryptographers in Europe and Asia that like would never be the ideal people to start a company and come to the Bay Area because this is like a specific interest group that only cares about a certain set of problems. And it doesn't mean that they were like not good or they were not qualified. It's just that they just never had access to this specific set of infrastructure to now try out what they could have done. And we're starting to see that. So for me, a lot of this is actually about talking to all the researchers that are in this space, understanding like what their priorities are, what they're researching, or just understanding, even from talking to the founders of companies in this space, saying, hey, like I know you're working on this protocol or you're working on this new architecture. What are these trade-offs, and like how do we actually make that better? Because you can constantly evolve. We're literally inventing new math on a daily basis, and we don't even know what the downside or like the problems from that could be. So it really is a super active community, and like being able to just kind of know what people are working on from a pure research first and practicality later level is sort of how I spend most of my time on. So like most of my day looks like just reading a lot of PDFs of people saying, hey, we can do this now, or this was, hey, look at this guy who made this thing, we can make it better. That's generally the tone it takes. And then from there, just talking to other founders saying, you did all these things, let's figure out what is the most obvious application for these technologies, because we still have to make them work with an existing system of how people go by their day. And that's kind of the part where everybody is figuring out.
First and foremost, if you could join me in a round of applause for Kartik.